Walk outside on a hot summer day and touch a dark-colored car. You'll probably regret it immediately. That's because most surfaces absorb sunlight. The darker the surface, the more heat it typically absorbs. Roads get hot. Roofs get hot. Buildings get hot. Entire cities get hotter because of it. But what if paint could do the exact opposite? What if a surface could sit under direct sunlight all day and actually stay cooler? It sounds impossible, but scientists have developed a new type of ultra-reflective paint that does exactly that. And honestly, the science behind it is kind of incredible. At first glance, it looks like ordinary white paint. Nothing special. No glowing effects. No futuristic appearance. No obvious technology. Just white paint. But hidden inside the material is something very different. The paint is designed to reflect an extremely large percentage of incoming sunlight, far more than traditional paints. Instead of absorbing energy from the sun, it sends much of that energy back into the atmosphere. And that's where things get weird, because under the right conditions, some of these coatings can actually keep surfaces cooler than the surrounding air. Think about that for a second. The sun is blasting directly onto the surface. Heat is everywhere. Yet the coated object remains cooler than the environment around it. It almost sounds like a magic trick, but it's real science. The secret comes from material engineering. Researchers carefully designed the paint to reflect sunlight across a broad range of wavelengths. At the same time, the coating helps release heat away from the surface through a process known as radiative cooling. Together, those effects create something surprisingly powerful, a passive cooling system. No electricity, no fans, no moving parts, just paint. And the potential impact is enormous. Buildings consume huge amounts of energy for cooling, especially in hot climates. Air conditioners run constantly, power demand increases, energy costs rise. But if buildings absorb less heat in the first place, cooling systems don't have to work as hard. That means lower energy consumption, lower costs, and potentially lower emissions. Suddenly, a bucket of paint starts looking like serious technology. And that's why projects like this get so much attention. Because humans usually think of innovation as something complicated. Robots, AI systems, massive machines, advanced electronics. But sometimes the most powerful inventions are surprisingly simple. Take a common object. Change the material, completely change its performance. And that's exactly what's happening here. The visual demonstrations are especially impressive. Researchers have compared surfaces coated with traditional paint against surfaces coated with ultra-reflective cooling paint. The temperature differences can be dramatic. One side becomes scorching hot, the other remains noticeably cooler, even while sitting under the same sunlight. And honestly, watching those tests feels strange. Your brain expects both surfaces to heat up. Instead, one behaves almost like it's breaking the rules, which is exactly why this technology feels so futuristic. Not because it looks futuristic, because it changes something ordinary in an unexpected way. And that's often how the future arrives. Not through giant machines, not through science fiction cities, but through materials quietly becoming smarter. One invention at a time. Because if paint can cool buildings without electricity, what other everyday materials are about to become extraordinary?